Alright, so phone's away. Number 2, I'll get a clean page so we can see. Alright, so what they did was factor it out of 3, and there's nothing wrong with that. If there's a negative leading coefficient here, they tend to factor it out. Okay? And if you do that, you're left with an x squared and a minus 25. And so that's the difference of squares. Remembering that we need to keep this negative 3 on our answer. You square x to get x squared, and you square 5 to get 25. So in our formula, that's our a and that's our b. And for difference of squares, your formula is a minus b, a plus b. So a minus b, x minus 5. A plus b, x plus 5. So if you missed that one, feel better? I need to leave it up for a minute. Okay. Number 4. This thing. First thing I check for is the greatest common factor. It doesn't have one. So, it's a trinomial. I'm left with this. So in the top, 12 times negative 6 is what, negative 72? And in the bottom, that's an understood negative 1. I need to find what multiplies together to give the top and adds together to give the bottom. So I come up with a list of numbers that multiply to 72. I'm not going to worry about the negative yet. So 1 and 72, 2 and 36, I think, what, 3 and 24, 4 and 18, 6 times 12, 7, 8 and 9. And I'm going to stop there because those are the ones that I can combine in some way to get a negative 1. If I make this a positive 8 and a negative 9, they multiply together to give negative 72, but they add together to give negative 1. So those are the numbers I'm going to use. And if I've only got one negative, I'm going to put it first. So 12x squared is going to stay. I'm going to replace this with negative 9x. And a positive 8x, and the negative 6 is going to stay. And then we can use grouping. Okay. On the left-hand side, greatest common factor for 12 and 9 is going to be 3. X squared and x will be x. So 12 divided by 3 is 4. I had an x squared, but I took 1 out, so I'm left with an x. Minus 9 divided by 3 is 3. And I took that x out. Bring down the plus. 8 and 6 is going to be 2. They don't both have x's, so I'm stuck there. 8 divided by 2 is 4. Leave the x. Negative 6 divided by 2 is negative 3. My parentheses match. So one of my factors is going to be the parentheses that they have in common. The other one, I'm going to put these outside pieces together in that parentheses. So if you missed that one, feel better about it. On its way. Okay. All right. Any questions from the problems that were posted online? Practice problems from sum of cubes, difference of cubes, difference of squares. Once, twice. So, all right. Today we are solving quadratics using a variety of methods. It's one of the types of problems that has the most applications with it. I'm going to focus on mechanics today, maybe some applications on Monday. We're just kind of looking. Bridges, those guide wires that they use when they do calculations for that, they have to use quadratics. They're parabolic. Satellite dishes are parabolic. Motion tends to be parabolic. Now, how many of you had quadratics in Algebra 1? Okay. If you took it in the 8th grade, did they call it Algebra 1 or did they call it coordinate algebra? Algebra 1? Okay, so did you have quadratics there? Maybe. Okay.
If we do not
Well, if not, you'll learn it now. Okay? All right, so quite a few different methods for solving quadratics. Quadratics is something that has an x squared as its highest exponent. Okay? We're going to go through kind of one method at a time. I have lots of extra examples just in case we need them, but we can skip them if we don't need them. And then at the end, probably Monday, we're going to throw them all together and figure out when it's best to use one method and when it's best to use another. Okay? So, first, that was fast. First, we're going to solve quadratics using square roots. Okay? Trying to get x by itself, and there's an x squared, we can use the square root to get rid of an x squared, right? We've done that before with inverses. Ready? Alright, what I want you to notice with these problems, those in the back, I think you'll be able to see it better if I do it like this. With these problems is it's got a squared piece and it's got a number, but notice it doesn't have an x piece. There's not like a plus 2x or a plus 5x. If it only has an x squared and a number, a constant term, you can use square roots on it, and it's much faster. There's a couple methods to do this when we could actually use this one by factoring as well. And so when it gets to test day, you can choose. But for now, we're going to use square roots. Okay? So if I want to get rid of the squared, what can I do? Take the square root of both sides. Square and the square root cancel each other out, right? What's the square root of 9?
3.
3. There's a little bit more to it than that. We haven't had to talk about it until now.
Plus or minus 3.
Plus or minus 3. Is it true that 3 times 3 is 9? But isn't it also true that negative 3 times negative 3 is 9? So there are two things that you can multiply by itself to get 9. And we have to acknowledge both of those. And it hasn't popped up until now. You haven't had to know that until now. Okay? But now we do. When I take the square root of something from now on, I need to put plus or minus on it. So I've really got two answers, x equals 3 and x equals negative 3.
Can't we just box up the
Yeah.
one above it?
I want you to get used to seeing it both ways, but either answer. I tend to, if it's just me, I usually box out. Okay? Now, we could have factored that using difference of squares if you wanted to. You got choices. I could bring the 9 over to the left-hand side by subtracting both sides by 9 and get x squared minus 9 equals 0. Would it be okay to do that? And that's the difference of squares. X minus 3, x plus 3 equals 0. If I've got two things multiplied together to give 0, doesn't at least one of them have to be 0? You can only get 0 by multiplying something by 0, right? It's either going to be 0 times something or something times 0. So you set each piece equal to 0, and you solve for x. So if I add 3 here, I'm going to get x equals 3. If I subtract 3 there, I'm going to get x equals negative 3, and it's the same thing. Which method's faster? This one. Does that mean you have to do it that way? No. Some people really like to use difference of squares, and that's okay. So far, so good. Can I move it? Alright, on the first one that we did, we took the square root of both sides because the x squared piece was by itself. Do I have that here? No, but I can make that happen. I could also use difference of squares, but since I'm trying to model the square root method for you, we're going to do that. I showed you that on the first one. Okay? So I can move 25 over to the other side. If it's a minus 25, I get rid of it by adding, right? So is it okay to take the shortcut that if it travels over, I change its sign? Are we okay with that? Okay. So I'm going to rewrite this problem as x squared equals a positive 25. Do I have the x squared piece by itself? So how do I get rid of the square? Square root. And now we know that the square root of 25 is not just 5, it's what? Plus or minus 5. And you can box that up, or you could list them out separately, either one. I think the software that I use to make your test writes the answer like that. Those answers. Okay? You can box that up as well. Not so bad. These are pretty easy. Pretty quick. Can I move it? I don't think we need to do that one. Let's do this. Take a minute, write it down. Now this one, I don't have a difference of squares, so that option is off the table, right? First off, it's not a difference. And secondly, 10 is not a perfect square. You see the difference? Okay. I still need to get the x squared piece by itself, so is it okay if I say a positive 10 on the left is a negative 10 on the right? How do I get rid of the square? Square root. The reason we do these topics in the order that we do them in, on the left, square and the square root cancel each other out. We know that when we take the square root of something now, we have to put plus or minus. Tell me about the square root of negative 10. Tell me about the negative part. We're going to have an I on our answer. Okay? So we had to have that unit first. Okay? So we're going to have an I. Is there a perfect square that goes evenly into 10? No, so it's going to be stuck inside the square root. That's why we had to have that unit before this one. Okay, it builds. So we're going to have I on the outside and the square root of 10. So some of these answers are going to look weird. They're building on what we've had before. Good? Anybody need more time on that one? Can you see that in the back? Okay. Sometimes we got to do a little bit of work to make it fit the form we want. I need to get that square by itself, so what should I do? Add 4, but there's already something over there, so I really am just adding 4 to that, right? Now what? Okay, square root. What am I going to put on my square root from now on? Plus or minus, and the square root of 36 is 6. Good? All right. Take a minute, write that one down. And I have to do two things to get the x squared by itself first, right? What should I do first? Subtract 4. So 3x squared equals, what is that, 18? X squared is not by itself. What do I need to do? Divide by 3. So x squared equals 6. Now what? Square root both sides. And from now on, we know that every time we take the square root, we're going to put what on our answer? Plus or minus. Is there a perfect square that goes evenly into 6? No. Just take the square root of 6. How do we feel about using square roots? I like them. Remember, you can only use them if you've got x squared terms and number terms. If that was a 4x, square root's not an option yet. Okay? So get used to seeing what they look like. X squared and numbers, no x term. So, scale 1 to 5, how do we feel about square roots? Ready to move kind of on? Let's do one more. Can you bring the water from? Alright, what should I do to get the x squared by itself? Good. No, square root's by itself now. What do? I said that wrong. Squares by itself, square root it. I'm really bad to do that. Put what on my answer? Plus or minus. Is there a perfect square that goes evenly into 162? Find it for me. 81. 81 times 2. 81 inside a square root comes outside the square root is what? 9. Alright. Think we can move on. Factoring. Well, we just did. Except now we're going to apply it. Okay? So, take a second, write this down. Our directions are going to be solved by factoring. Please notice that square roots would not be an option because of that 3x piece. Because what's going to happen at the end when we throw them all in the pot together is you have to kind of start recognizing when you can use which method. There is one method that works for everything, and some people choose to use it for everything, which is good. We're building for that. That just cracks you up and keeps me awake. All right. So, left-hand side, that's a trinomial with a leading coefficient of 1. So we're not going to have to use the x method. So let's factor it. The x squared, you can split up x times x. I need to find something that multiplies together to give 2, but adds together to give 3. Positive 1, positive 2. I wasn't really sure what I heard, and then suddenly my brain just stopped. Do they multiply together to give 2? Do they add together to give 3? So, plus 1 and plus 2. So our first step is to factor it. I'm going to put that down here. Because it kind of looks like it's multiplying that thing. And then we talked about it with the very first example. I need to solve for x. I've got two things that are multiplied together to equal x, to equal 0. There's only one way that thing can happen, is it's something is 0. That make sense? Okay, so set each piece equal to 0. And solve for x. So for the first one, you can either think subtract 1 from both sides or move that over to the other side and make it negative. You're going to get x equals negative 1. The second one, you can either think subtract 2 from both sides or move that over to the other side and make it negative. So taking our factoring and just going one step further. We're going to spend a couple days on factoring before we start. Alec, feeling puny? Feeling puny?
Just tired.
All right. X squared minus 8x plus 15. Easy trinomial. Leading coefficient of 1. which means I can take my x squares, split it up, x times x. Notice I couldn't use square root method because of that x term in the middle. I need to find something that multiplies together to give 15, but adds together to give negative 8. Negative 3, negative 5. Do they multiply together to give positive 15? Do they add together to give negative 8? Yes, so we'll use those. And so once we have it factored, what do we do with the individual pieces? Set them equal to 0. So you can either think add 3 to both sides or move that over and make it positive. So x equals 3. And the same thing here, either add 5 or move it over and make it positive. We're not going to do a tremendous amount of these that have a leading coefficient bigger than 1, because when it's got a leading coefficient bigger than 1, or different than 1 I should say, there's another method I think that's easier for most people than factoring it using the x method. Except some people just really like to factor. Any more time? We'll do one of them. We're not going to do a lot of them. We're going to do one. Always check for greatest common factor first. It doesn't have one. Leading coefficient's not 1, so we're going to have to use the x method. 2 times negative 4 in the top gives us negative 8. Negative 7 in the bottom. Need to find what multiplies together to give the top and adds together to give the bottom. So 1, 8, 2, and 4. Which one can I combine to get negative 7? 1 and 8. Both positive, both negative, one of each. What? 8 negative and 1 positive. Multiplies together to give negative 8. Adds together to give negative 7. I agree. So 2x squared, replace this middle piece. Negative 8x, positive 1x minus 4. You could just put plain old x if you wanted to. That's fine. And use grouping. See how that goes. That's okay. Alright, on the left, greatest common factor, 2x. That's going to leave me with x minus 4. Bring down the plus. I got to factor something out. What am I going to pull out there? 1. That's going to stay x minus 4. So it factors x minus 4, 2x plus 1. And what do I do with each factor? Set them equal to 0. So x minus 4 equals 0. 2x plus 1 equals 0. Here just move the 4 over, so x equals 4. Here move the positive 1 over. It's going to be 2x equals negative 1, but I don't have x yet. What do I need to do? Divide by 2. So factoring we've been doing with one extra step. Set the factors equal to 0, solve for x. Not terrible? Can I move it? Oh, we're so sleepy today. Completing the square. The hardest of all the methods. Okay? However, I tend to ask these questions a little bit differently on tests. The majority of your tests will be choose your method. Doesn't matter to me which method you choose. If all it has is an x squared term and a number, I'd square root it all day long. If it had an x term in the middle and it was easy to factor, if I could see quickly how it factored, I'd factor it. But if I couldn't see quickly how it factored, I'd go with the last method we're going to learn. This one I'll show you in just a second how I tend to ask these questions. Okay? How many have seen completing the square before? That's good. Okay? Alright, completing the square. Here's what we're going to do. We're going to take the number piece and we're going to throw it to the other side every single time. Okay? And then when you do that, I want you to go ahead and put a plus sign here and leave you a space. Because we're going to add something to both sides. So we can't just add to one side. We've got to add to both sides. And I'll never make you do a completing the square with a leading coefficient other than 1. Those are just difficult for the sake of being difficult. Okay? Alright, so we have to figure out, what we're trying to figure out here is what number can I put in this blank that if I were to factor it, I get the same factor twice. That's what it means to complete the square. Square means something times itself, and I want the same factor twice. You do it the same way every single time. Take this number, ignore the negative, the 14, divide it by 2, and then square it. Half that number squared every single time. Half of 14 is 7, squared is 49. That's the number you're going to add to both sides every single time. So on a test, the way I tend to ask it to make sure that I'm assessing you on completing the square, it will say, what number should be added to both sides to create a perfect square? You would answer what? 49. That's the number I added to both sides. And then it'll say, express it as a perfect square. That's filling in the parentheses. Same way every single time. Are you ready? This letter, this sign, half that number. Every time. This variable, that sign, half that number every time. If I were to write this down twice and multiply it out, I would get that. Okay? Equals, clean up the right-hand side. What's negative 46 plus 49? 3. So far, so good. Now, just because I don't test you on the entire method doesn't mean I'm not going to teach you the entire method. Okay? Now, I'm still trying to solve for x. My x is trapped inside a squared, so I'd like to ditch the squared. How do I get rid of a squared? Square root.
What happens to 49 on the other side?
It's really there. If we were to multiply, look over here on the side. If I were to, I replace this whole thing with x minus 7 squared. Okay? X minus 7 times x minus 7, that's what it means to be x minus 7 squared, right? If I take the x through, I'm going to get x squared minus 7x. I take the negative 7 through, negative 7x plus 49. Oh, 9. There's a 9 there, right there. Okay? So it's the same thing. It's just a shortcut, a shorthand. Alright, so, over here on the left, square root and the square cancel each other out. We now know that every time we take the square root, we have to put what on it? Plus or minus. Is there anything that'll go break down in 3? Do I have x by itself yet? No, I'm going to take this negative 7, I'm going to put it on the other side, and I'm going to put it in front of that plus or minus. And that's what your answer looks like. So I could ask you questions like this. If this was my answer, would that thing have factored? Have we factored anything that factored with square roots in it? No, if you got square roots in your answer, it's not going to factor. Okay? It wouldn't have been an option. We could have tried. We'd come up with a list of numbers and nothing would have worked. It's prime. Weird looking, but not terrible. Okay, let's try this one. Take a minute, write it down. Alright, so we're going to use completing the square. Our first step is usually to take the number and throw it on the other side, but that's already there for us, right? Okay. We couldn't use square root method in the beginning because of this 6x. So, we're going to have to add something to both sides to complete the square. Ignore plus or minus, doesn't matter. Half of 6 is 3, squared is 9. So my first question on a test, if I'm asking this, is what number must be added to both sides to complete the square? You would answer me what? 9. The next question would then be, express it as a perfect square. What am I going to put in parentheses? This letter, this sign, half that number, every single time. Clean up the right-hand side. Good. Do I have x by itself? What should I do? Square root it. Square root and square cancel each other out. What do I have to put on front?
Plus minus.
Will square root of 5 break down? No. Do I have x by itself? No? Oh, we're so sleepy today. Plus 3 on the left is going to be what on the right? Minus 3. Where do I put it? In front of the plus or minus. So now that we've done a couple of those, how many of you remember having seen that before? A lot of 4s. Okay. Good. I'm going to try one more of those before lunch. Question? Thought I heard a question? Okay.
Oh, yeah.
Okay. Now, to the first couple, we've gotten some weird square roots in our answer, so that lets us know it wouldn't have factored. Okay? So the only option to us at this point is completing the square. We're going to do this one, completing the square. What would my first step be? Take the 7 to the other side and leave me some space, right? What number is going to go in the blank? 16. How'd you get 16? You're right.
Eight's 4 and 14's 4, 16.
Half of 8 is 4, and then squared is 16. Why can't I say it doesn't matter whether you use the negative or not? Right. If I looked at it as half of negative 8, that's negative 4. Negative 4 squared is still going to be positive 16. So it's just easier to not deal with the negative at all. Okay? So first question would be, what should be added to make to complete the square? And you'd say 16. Then it would be, express it as a perfect square. What goes in the parentheses? X minus 4. Good. Clean up the right-hand side. What do we get? 9. Oh, 9. That's good. It's a perfect square. Square root both sides? X minus 4 equals what? What kind of 3? Plus or minus 3. So far, we've just had like weird square roots in our answer. So this minus 4 is going to go over as a positive 4. Where's it going to go? In front of the plus or minus. So x equals 4 plus or minus 3. Well, I can clean that up. Before I couldn't. One was a square root, one was a number. So this is really 2 problems in one. 4 plus 3 and 4 minus 3. So 7, 1. So I got nice normal looking numbers. That thing would have factored in the beginning. Okay? There's no square roots collecting that. It would have factored. Okay? Give our brains a break for a couple minutes before we go to lunch. Right there. I'm running low on tissues. I need to put tissues and hand sanitizer on my list.
Just live one house if you want.